Hi, welcome to this Open Security Summit session in January 2022. We basically going to be looking, at threat modeling, why, what, and how, and Brook is going to lead us through it. So over to you.
Thank you very much, and hello. And I hope this is going to be useful. I want to encourage you to participate. And as I go through my little introduction here, I hope to set some context. So I hope you'll indulge me a little bit in maybe some stuff you hadn't expected. But I want to set the context for threat modeling in its larger context around software security first, before we dive in, if you don't mind. So, hopefully, many of you will know this and some of you won't, but I want us to all have kind of the basic background in where we are. And this should be no surprise to anyone. We're all collateral damage. That's what's happening here. There's been a cyber war, in my opinion, going on for at least 10 years, maybe more like 14 or 15. And it's pretty hot and it's pretty active. And those of us who are not maybe involved in all these geopolitics, maybe we don't even care. We're still collateral damage. It's still affecting us. And there be pirates out there. If you think about it, the internet is a global commons, just like the open oceans were in the golden age of piracy. And because of that, there's lots of opportunity, and humans are clever, and they will pick up on any opportunities they can find. If they can get some leverage, someone will take it somewhere. And that's kind of the reality of things. I'm sure this is not a big surprise to most of you, but let's bear that in mind, is that it's quite hot. There's no doubt if you put an interface on the internet and it has a routable address, that it will get probed. It's just a matter of how long, anywhere from about a few seconds to maybe as much as 8 hours if all the IP sweeps are way at the other end of if you get lucky, but you will get probed and you will get attacked. It's going to happen. So, there's no doubt about that. So let me put some software security context in here. According to Evans data, there are 28 million programmers on planet Earth. And I'd ask you to consider, how many of those do you think have had some kind of training in software security? How many of them work under an SDL, a security development lifecycle? Call it what you will. How many of them work under an AppSec policy? I often work with my clients, especially smaller ones, and they will say, no policy, no policy. And even companies that have been going, that have a really good revenue stream and solid technology, will say, no, we haven't done that yet. They may, think about it. How many do you think of those 28 million programmers have actively used at least one software security tool in their development? My guess, and it's just a guess, I don't have any data here, so I can't really say for sure, but my guess, if I said 2 million, that would be a lot. If I said 1 million, I'd start to feel comfortable, and where I'm getting that number is I'm thinking about how large development teams are in major tech companies versus companies that aren't tech. And I'm just sort of mentally adding up the numbers. 1 million, maybe 1.5 million, maybe 2 million, and maybe 28 million isn't really accurate. I haven't looked at the research from Evans data. I just took their number. But nevertheless, that's a lot of people. And I'm going to opine here that the vast majority of them are not thinking about software security. So does that matter? I mean, they're doing people's websites and stuff. Yeah. Yeah, it matters. It matters because somewhere buried in your deep mesh of dependencies in your open source is code written by the other 27 million programmers. Somewhere buried in the mesh or network of APIs that you call, that someone else calls, that one of your callers down 3 levels calls, is code written by some of those 27 million programmers who don't know anything about software security or don't really think about it. I mean, I have seen things like major tech companies deciding, letting their teams decide what to fix based on a percentage of defects. Now, if you've been around long enough, you know that that's great in manufacturing, but it's terrible in security because, first off, it's about risk. It's not about percentages. Doesn't matter whether the one thing that will get you is in the top 5% or down there in the bottom. It's got to be fixed. And you have to do the analysis to know that that's the thing that needs to be fixed. And so choosing percentages is going to release a lot of things that can provide leverage for attackers. So, you know, buried deep here are software that's probably you're using somewhere that's written by people who haven't threat modeled and don't even know what that means. The state of our art is also rather difficult. I wish there was one panacea thing I could tell anyone to do, that if they just did that one thing, they'd be golden. I had a CTO once say to us, I pay for static analysis. Doesn't that take care of my problem? And this guy has gone on to a stellar career. It's not that he's, you know, dumb or anything like that. He's not. It's just that he misunderstood the problem and the complexity of what we're dealing with. In order to get any kind of assurance, we got to do a whole lot of different things. It's a big puzzle. And some of these things have tremendous dependencies on other things. And doing those well. I don't have my dependency graph in this deck. It's in, I think we put it into building in security at Agile Speed, but it's out there. And it's ugly. It's really ugly. It was the result of a whiteboard session that Dr. James Ransom and I were doing for weeks on end, trying to figure out how to do this. Excuse me, stupid phone. Yeah, it's a puzzle. There's no one thing. You got to do a bunch of stuff, and you have to do them reasonably well. I mean, I'm not going to go into that here. I want to focus on threat modeling, but still, there isn't a single, I mean, threat modeling isn't going to solve your problems for you. It's a piece of the puzzle, an important piece, don't get me wrong, but a piece of the puzzle. And then we get to vendor marketing. Each one of these, and forgive me if you're a vendor and I'm insulting you by putting this up here without getting your copyright here, but these are all publicly made statements. Strategic security solution that covers all your security gaps. I put in all the emphases here. Simplified cybersecurity. Secure your sites, apps, APIs, and infrastructures. Yeah, one tool is going to do that for me? I think not. One suite of tools? I think not. You know, I'm sorry if you're a vendor in the room, but your marketers are making this more difficult. We need you. We desperately need you. And we desperately need your products. But please don't tell us silly things that we know aren't true. And so this is kind of our world. It's not a pretty picture. And I wish I could say, yeah, software security is easy. Just do the right things and get a good policy. Nah, that won't get you there. We tend to do ad hoc. I mean, in threat modeling, there tends to be a lot of ad hoc secure design. One of the things about being a consultant the last few years is that I've been able to talk to a lot of different companies about what they do. And while that's not a scientific survey, and I don't want to be clear about that, I don't have that data yet. I hope to get it in the next year or so. But still, anecdotally, I can tell you, it's not that people aren't thinking about security. It's that they're limited by what they know. And people are taking responsibility so far as they can. And another problem is that I see, and I'm sure a lot of people in the audience will resonate with this, is late threat modeling. I mean, the famous quote that's happened to me dozens of times, probably hundreds of times, is we can't threat model, we haven't finished the architecture. Anybody on the call know what's wrong with that statement? We can't, well, I know Isar, you do know what's wrong with that statement, but anyone else? We can't
I think what we
start
should
the
say is
threat
that
model.
you should threat model because you haven't finished the architecture.
Exactly. It's part and parcel of architecting is what I'm saying, right? And, you know, so I have to convince them, yeah, no, you're already late. Let's get the work. Or threat modeling exactly once. It's quickly obsolete if, you know, especially in today's rate of change. These are typical problems that are very widespread, very widespread. So, you know, threat modeling, I've talked a lot about it, but I haven't really defined it. But I want to convince you that actually you know how to threat model. All of us do. And let's step away from tech for a moment. If you're getting into your car and driving without a threat model, I don't want to share the road with you. I mean, literally, if you think nothing can happen to you and you're just such a great driver and your car is so great, well, I do see a lot of SUVs going over snowy passes that seem to be driving that way. But let's eliminate that, even if you drive an SUV. Let's say you have a threat model. All of us have a threat model. Think about it. You threat model the obvious vulnerabilities. I've got decent tires. I'm not going to go out. Or if I do have tires that are edgy, I'm going to drive differently, and I'm going to account for that because it's part of my threat model. I also know that things happen unexpectedly. So I'm taking a constant watch for a driver that's going to pull out in front of me. If I see a car pull out, you know, come to a stop on an interchange, I'm watching to see if they're going to pull out in front of me so that I can react quickly. I'm keeping an eye on the oncoming traffic to make sure it doesn't, you know, some drunk doesn't come over the median at me. I'm doing all of these things, and presumably you are too. I'm thinking about how fast can I drive today in these conditions, as opposed to completely dry conditions. You know, you have a threat model. We all have a threat model. And so everybody knows how to do this because it's part and parcel of living. This is not something special and, you know, only senior security people can do. It's something we all do, but we need to apply it for secure design. So let's get into a little moment here. This is a recreation because I didn't want to expose somebody's IP from one of my clients. However, I actually got a threat model. The architecture here is out of one of my books, so I know I can't be sued for that. But nevertheless, this is what the threat model looked like. Just take a moment and see what this looks like. There was no, by the way, there was no like explanation after it. This is the threat model that a professional delivered and got paid for. Anybody want to comment? I want to be clear, I've got nothing against Stride. I teach it. It's a great way to start if you have never done this before. I think it's a good opening, if you will. So that's not the point here. But anybody want to comment? I mean, this is completely useless because I don't know what the spoof or the tamper is. And because of that, I can't defend against them. I have to know what you're tampering and how you're doing it, how you're hiding your actions, i.e. repudiation. What information are we disclosing? And where was that in order to do something with this? This literally was my students at university do better threat models than this by a huge margin. And they're just learning. This was actually a threat model. They had STRIDE, and they got paid for it, which is surprising to me. So, we have to know what it is we want to do and not confuse stride. So let's take a look at a threat model that may be useful. I'm sure that most of the people on this call have recently been watching the solar winds. Maybe you were affected by it. I mean, 18,000 customers. It's quite likely that we have people on the call who were affected by solar winds. These are some headlines that I pulled up. I mean, it's somebody's video that I just grabbed the image of, but I wanted you to just look at the headlines and what folks were interested in. If you look into the analyses, and I have spent considerable time looking into the analyses, you will not find, it took me 2 weeks to find how they think it got started. Everyone's focused on the loss of the SAML keys. Very important. And how clever that is. Actually, is it really clever? If you know anything about SAML, if you have the private keying material, you can federate. Boom, right? I don't know that it was all that clever, but there was a lot of fascination with that. And then the other thing that people were fascinated with, of course, was getting an entire backdoor suite, just part of the download, part of the package. And it's pretty disastrous. I don't dismiss it, but is that really important from a threat modeling perspective? Well, yeah. But let me show you, and this is a very bad drawing, and I promise, I apologize. I just kicked it out really fast. I just kicked it out really fast because I ask you, they think that the original compromise was an O365 account of a new developer. Do you see anything wrong in this picture from a threat modeling perspective? I invite you to comment. This isn't a trick question either. Anybody want to comment?
So you got Shane is saying there's a bit of a lack of detail. John has mentioned no MFA, no roles or permissions.
Exactly. Table stake security. Table stake security is missing here. This new developer had access to the repo, to the build deploy system, to the federation. They were able to get all of those off of an O365 account. To me, that's what's interesting from a threat modeling perspective, is that initial, and then what was missing in a controls space. And these are all table stakes security. I want to point out, there's nothing fancy here.
But here's the thing, right? In order to map that out, you kind of need to do what I sometimes like to describe as scenario-driven threat model, right?
Yes.
Where you kind of, you can't just talk about threat model, because I feel that when you do that, you mix in abstractions, right? It's almost like you want to look at a scenario, and then you go, okay, let's threat model that scenario. And it's actually why I like to do threat models sometimes on top of incidents, because
Yep.
we know something happened. You don't have to go theoretical. If this would happen, if that would happen, you go, shit just happened, right? Now,
Yeah.
let's threat model to understand how, what some of the root causes are, but also what are some of the other problems that this highlights, right? So in this case, yeah, I think we
Exactly.
want to talk about the threat model from the point of view of actually account compromise, right? Then all those access controls become laser sharp focus, right?
That's right. And so I paid Denise for that. I owe him lunch now, or dinner. Yeah, exactly, precisely. And I prefer scenario-based, which is why I'm not real fond of attack trees, because I feel like they waste my time trying to find every single thing. I'm going to get into this in a little bit, in a moment, but it's this fascination with the deep hacker, which I think is and I want to be clear. We need, and I've written about this, we need security researchers desperately, because we don't have a good process of external commenting on our engineering in software. And for me, security researchers are the folks who provide that piece of the puzzle. The external comment, you didn't get this quite right, and here, let me prove this to you by taking over your software or doing whatever. And that's very important. I don't want to dismiss that, because I think it's key to how we're operating and to software security. On the other hand, there's this fascination with private keying material versus the really grunt, almost unimportant, almost uninteresting, I guess. Maybe it is uninteresting or whatever, but it's interesting to me, just what you said, Denise. The grunt account roles and setting that up correctly, and what does a newbie get and what do they need, as opposed to someone who's more experienced. And do we have separation of roles, because not everybody needs to control the build and deploy system, and so on. And that's what seems to be missing a lot of the times, is this fascination. And I'm gonna dig into that a little bit more in a minute. But
So I would say that, as expand on that one, which is we need to take the threat actor into context, right? So the threat actor, i.e. the who or what, right, is the entity that can exploit that particular vulnerability, right? Because it's important, right? Because when you take the threat actor and the threat actor, I kind of view that you need to take into account not just their skills, but their time, their motivation, their business model, what they want to do, and also what do you do? Because a threat actor for a particular company, the same individual with the same resources might behave very differently against another company, right?
Well, that's very true, because attackers are intelligent, adaptive, and creative.
Yeah.
That's the most important thing to remember. On the other hand, there are real differences. I don't have that in this deck, but I'm going to expand on it just because you brought it up. I am really in favor, and I know some people don't like to do this because they think it's irrelevant. All I need to know is that there's a technique, and it will be done, and I think it will be done this much likelihood. But I think threat actors are very important, and here's why. Let's say you're producing endpoint security software. And because I technically led product security at an endpoint, a security company, but they did a lot of endpoint stuff, McAfee, for a number of years, I have this example really written into my skull because it was brought to my attention. And we're trying to figure out who our threat actors are. And for enterprise, obviously, we have nation states, because some of our enterprise customers were nation states. And so that's an obvious. When I went to the consumer folks, they said, if people who are the targets of nation states are using this software, they're using the wrong software. We do not consider nation states to be one of our, that we're going to have it as part of our threat model, because there are other business drivers, and that's not our target audience, and we don't need to protect at that level. And there's a prime example of something where the threat actor, I think, is critically important, because in the enterprise space, especially when you have governmental customers, you're going to have nation state actors, and you better be good enough to at least do something in that arena, as difficult as nation state actors are. Nevertheless, in the consumer space, they felt, wait a minute, you shouldn't be using this product if you have nation state attackers. This is, for cyber criminals primarily, to prevent cybercrime. And it's a really different business model, because cyber criminals, stereotypically, any one cyber criminal could fall out of this, don't like to spend money on R&D. They don't like to invest money in R&D. They like the known and the proven techniques, because it's cheaper and there's lots of vulnerability out there. Like I said, the golden age of piracy. There's lots of undefended ships out on the internet, if you will. Whereas if you're doing if you're protecting nation states, you got to have a much higher level, and you don't need to worry about performance quite as much. So there's a performance trade-off there that's very important. I don't want to go into that, but it's an example of where knowing your attacker is critically important and what you're protecting against. And not everybody is a nation state target. I mean, collateral damage, yes, but direct targeted, not so much. And the reason I bring up nation states is they tend to be really sophisticated, and they will work on something forever. So that makes it very hard.
But they also have very different motivations, right? So,
very different.
Then you need to look at what business are you in, right? Because
yeah, exactly.
Some business they absolutely have to care about, but others that you almost have to say, look, you're not ready for it, and and you need another zero in your security budget if you actually do want to defend against them, right? So,
yeah, exactly. And that's very important. Interestingly, while we're on this topic, because I don't have it in my deck, unfortunately, while we're on this topic, you only need to do this once and then review it. Your attackers aren't, unless you change your business model, your attackers really, your stereotypic attacker lumps or types aren't going to change a heck of a lot. So, it's not something that you do in every threat model. It's much better to do it once, not exactly done, but once and reviewed. I think it's the right way to think of it. Once and periodically come back and do we still make the right assumptions? Has anything changed? But it's not something you need to do all the time in every threat model. It's better if a couple of people go away and really do this work and get it done and then offer it up, because it's just, it just saves some time. Know who your attackers are, know what their motivations are. And then, that will influence your threat model tremendously. I completely agree, Denise.
So you're saying that the threat models are like this gigantic graph, right? They're all hyper-connected, right?
Yes, that's very true.
So the other thing that I feel, and the point you're making is actually quite interesting, because one of the things I've found also, and I've seen this in companies, is that they did not realize, or they not took into account when their, Uber almost attack model, right, or threat level, at the company wide change, because they created a business model for the attackers, and like when you say the commercial attackers, especially the ones who are motivated by, exploiting some of the financial returns of the exploits. You can have a company that sometimes have a lot of security problems, but they never clicked, apart from ransomware, which of course any company can be exploited by that. But there's a lot of times where suddenly a small feature in an application means that you go from zero kind of problems to huge amount of problems. And the interesting thing about it is that when you fix that particular initial, let's say, gap that caused the amount of problems, the attackers don't go back to zero, because now you might have a set of attackers who have learned how to exploit that company or those assets. And now they go hunting for other ones because they now only need another piece of the puzzle to be able to go back into being exploited, right?
That's
so
very true.
There's something to be said for understanding, like I would argue that if your company is not being attacked today, and well, you probably should know about or notice, you should ask yourself, why is it? Is it because you are insanely secure, or because your company, when it aligns with the current threat landscape that you have, with your security protections, with your attackers, some of the dots have not been connected, either by luck or by something that you haven't done in your company or your organization, but that could change quite quickly.
You bring up a really important point. I think it's sort of implicit in what you're saying, which is the threat landscape changes.
Yeah.
It changes a lot. So classic example, we had a product at McAfee. I think it got killed, so I'm not revealing anything here. And besides, I don't work for them anymore, and haven't for a while. But I wouldn't ever reveal any of their secrets. That's just not the way I do my business. But nevertheless, they had a product that was written. Its design was done in 2003. Now, I was in security in 2003, and I remember very, very well what the main issues were. We were still dealing with worms, viruses, and networks. And application security was just beginning to really take off. Nobody would have guessed that my team, the application security team that I led at Cisco, would become the largest team and one of the most important in 2003. Nobody would have guessed that, I think. Because it was all about networks still, and all about endpoints. And because of that, their product design wasn't up to the threat landscape of 2015. Yeah. And finally, a customer noticed and went, I don't like this. We're really upset. But in order to change it, it was a 2-year journey, because they had been relying on that design for all those years, because it had been sufficient up until that moment. Yeah. I mean, in my opinion, they should have been redoing their threat model for years already, right? That's a different problem. But if you have legacy, you likely have stuff that was written for an entirely different threat landscape. Think of Spectre and Meltdown. Yeah. There's no vulnerability there. The CPUs were working as designed. It's just that design was thought of in 1995, I believe, yeah, and then started to be implemented in the mid-aughts. And that was an entirely different threat landscape, entirely different. And nobody thought to start changing things until it was an emergency. Now, I was working as a distinguished engineer, their version of distinguished engineer at Intel, we had just been spun out at McAfee right when that came down. So I was part of the embargoed folks, and got to work on it. And interestingly, there was a whole body of research that led, in hindsight, led to Spectre and Meltdown from that same group of people. So my guess, and I don't know this for a fact, well, my guess is that some fellow or principal engineer at Intel raised their hand and went, there might be a problem in the future with this. And business folks said, nah, I don't want to worry about it. That's my guess. Rumor, I don't know that this happened, but they certainly did not address it. And then they had a major problem, right? Because the threat landscape has changed so radically. When I did my first really large vulnerability, it was a worm in 1992 or 1993. And the tools I had to use were a disassembler, and that's about it. And I undid the worm by hand in the jump table of the operating system. Think about that versus Frida today. Just think about the difference between, if you know about Frida or any of the reverse engineering tools available today. It's like the difference between stone tools you're making, by smacking one stone against another, and steel. It's vastly different universe that we live in today. You think you can throw your secret into a static variable in your binary? Oh, that's so easy to find today. It was very hard to find in 1993.
Yeah. But the thing
things have changed.
But one thing I feel that we can definitely, align, and I would like to have more data about this, is that more and more I would say 99% the data that I've seen points this way, that there's a very direct correlation between ability to secure an application, right, and ability to make it secure, and the ability to make changes and to ship that product, right? And also,
I think you're right.
A company
That's right.
understanding of that product. Because the thing that I feel would be good to have more data about this is that every time you find an app or a network that you cannot patch, or you cannot fix, or you cannot protect, or you cannot threat model, or you ask, where's your documentation? They go, cool, let me know when you find it, because I would like to have it too, right? In addition to finding probably a security team that's fighting uphill, you find users, customers, support people, other IT teams, business teams that are insanely frustrated with their own system, right? The problem is that sometimes I don't think they diagnose the issue very well, where they go, let's rebuild a new one, or it sucks, it's legacy, let's ignore it, or we cannot do anything about it. Where I think in security, we can play a big role, because we could say, look, even if you don't want to do something about it, at least fix the CI pipeline, at least get to the point where you can do fixes, get to the point where you can start to fix things, because you will get not just advantages in security, you get advantages in business, right? And I think there's a world here that we need to start to say, you need to do security, not just for the security benefits, but you need to do security because of the force multiplier within the business. And when you look at
don't you think that just being a responsible developer and participant in the software creation process? I mean, I've won a couple of awards in the past for calling out things just because, as someone who's written a few 100,000 lines of commercial code myself, I'm an architect, I call out a bad architecture, irrespective of whether it has any security implications or not. It's just not very good.
Yeah, but
we have some larger responsibility to bring our skills to the work.
Yeah, but how much political capital you had to use in those cases, or how it's still a very risky operation to do that, right?
It is. You can only cart from the sidelines, is the way I've always felt.
That's the thing. And so there's one little, one comment that you just made that I feel we especially in security make a big mistake on, which is I don't think the developers have the majority responsibility for writing secure code. Now, I want to caveat to this to say, of course, a developer that understands security will write better code, will write more secure code, etc. But is the ecosystem around the developer that will influence a lot more the security of the code, the environment, the application, etc. If you don't have the development cycles, if you don't have the focus, if you don't have the tools, if you don't have the mandate, if you don't have the architecture, it's very hard, and the training, right? It's very hard to get a developer, right, to do the right thing, even when they know.
Go back to this. This is what I'm trying to say. When you look at the puzzle, it's insane.
Exactly, right? So developers only control certain things here, right? Like, how many times you heard developers going, we only heard about what we're building after the business decided what we're building, right? They were not involved in the design. They were not involved in the grooming sessions. They were not involved in some of the architectures. They were basically given, now we're doing this, and you're doing this piece. And it's very hard at that time to have a big influence in what you do, right? So the developers ultimately, either they pay very big political costs for doing the right thing, or they go, well, I've been giving a piece of the puzzle, that's what I'm doing, right? Where I feel that we need to look at sometimes the ecosystem and see, for example, if you don't have a good CI pipeline, there's only so much you can do in security because you don't have good, you can't refactor fast. You can't make fast changes, right? If you don't do threat models, means you don't do information architectures, you struggle to understand the security implications of what you're doing, right?
Well, let's just take secure coding.
Yeah.
We've got a lot of people on this call. Presumably some of you have written significant amounts of code. I know there's at least one of you who writes perfect code, but frankly, I don't. And what one of us, if you've been around for a while, has written a piece of code that you were really proud of, and you think this is really this is elegant, this is good, this will really work.
Yeah.
And a bug shows up in the field about 6 months after the code's gone out. And you go back and you look at the code after not having stared at it to write it, and you say, it's a good thing this isn't executing because it's all wrong.
Yeah.
That has certainly happened to me, and I get a lot of nods from people who've been around a while going, yeah, that's happened to me. Yeah, I've done that. I make mistakes. So there's a thing that happens in security that really bugs me. I have to say it's a pet peeve where we say, oh, developers are dumb.
Yeah, exactly.
I've not met a lot of dumb developers. I have a few, yeah. It's a big population, 27 million, 28 million, whatever. But still, I've met a lot of really sharp people who care, and they still make mistakes. And whenever I try to do something new, whether it's coding or anything else, I am going to make more mistakes. And we don't give people enough support, as to your point, around that.
Yeah.
That people can really try to work safely, making mistakes, and then find their security errors.
Yeah. And that's, look, it's exactly spot on, right? Like, the idea, that's what I was saying, that developers are not the majority of they're not the biggest factor in writing a secure application in a secure environment, because it's the ecosystem around them, right? Is the fact that how much time were they given to develop that feature? How much time do they understand what they're coding? How much were they given that code and then having to write on top of it, right? How much testing framework it exists, right? Because if you're writing code but there's no testing framework, you're basically going to write code that you have not tested, and you're not being given the time to write the test. So now you create that model, right? So I completely agree with you that we need to move this idea that it's the developers that are our problem, because they're
the people who are doing it. We have to support them. That's my job.
Exactly.
That is literally my job, is to make them successful and securely.
Yeah, and threat model, I think, is a great catch, right? Especially when you align threat model with architecture and documentation and how things work. Because when you get it right, people want to know that, right? And threat model, it's something that we can mandate from the top down, because it's an easy. So my party trick tends to be, if you don't do a threat model, then you don't understand the security implications of that feature or the application. So accept the risk. And
you don't. And importantly, I have 5 principles I use. I didn't put them in this deck, and I apologize for that, but I could dig them up if people are curious. But they're also in a couple of my books too, and in lots of presentations I've done in the past. So you can go find this stuff. But when I tried to reduce, and this is under the pressure of working with a lot of really top-notch enterprise architects who say, if you don't know what you're designing to, forget it, go home. And so I wrote some software security behaviors, if you will, and it turns out that only 1 out of 5 is implementation, that is secure coding.
Yeah.
The other 4 are actually, you have to design them. If you don't design them, you won't get them. You'll never get those behaviors. And what I mean is resilience, self-protective, and resilient. Fail well. Think about it. If there's bugs, and there are always bugs, and they fail, and some of them have software security implications, some of them can be leveraged. You want to not fail open so that everything, you give away the store. You want to reduce the, possibility of failure. So you assume that everything's going to fail.
Yeah.
That's just old structured defensive programming, and I learned that 40 years ago.
You can thread model that, right? And he's a
Yeah.
great coach. And by the way, Avid, I just made your co-host, right? So you can chip in if you want, right? Avid just made a great comment. Says developers are sometimes part of the problem, but they're always part of the solution. Great.
Yeah. Wow. Yes. Always. Always. So if that's Isar that's in here, jump in, Isar, please. Isar and I go back a long way by now, and he's one of the co-authors to this that I'm putting on the screen right now. Yeah, we've done a bunch of different things together, lots of co-authoring.
If you want
Way too much, maybe.
bring you guys in, you can always raise your hand,
Yeah.
right?
Yeah,
and
and
we'll
jump
bring you
in.
guys But look, the point
Yeah,
of the summit
please.
is to have these conversations, right? So me
Yeah.
and Brooke are feeding on each other, but feel free to chip in.
Yeah, jump in, please. That's what I was hoping for. That's what I love about the Open Security Summit versus, RSAC, where I get up on stage and I'm the big talking head, and you gotta think that I know something about this, and hope and pray. Yeah, it's better to have a conversation because we all have pieces of the puzzle. I do want to point this out. Isar and myself and 12 other people spent about a year trying to think about threat modeling and reducing not the methods. We didn't deal with methods, but with all the other stuff around it, and come up with this manifesto. And I want to highlight that because a lot of what we're saying is actually in this manifesto. Now, we didn't agree about everything. It's true. And it was a self-selected group for a variety of reasons. Nevertheless, it's people I really trust and really love working with, some really, I think, brilliant minds in security. And so we were very lucky that way. I think if you want a starter, if you're new, or if you want to think about how do I address some of the problems, go look at the manifesto, because we've tried to reduce these larger conversations down into really bullet points in a way that I hope is very succinct. Anyway, this is our definition. And you could also use Adam Shostak, another fantastic practitioner who's certainly presented here in the past, I think, one of the greats. What can go wrong? What are we working on? What can go wrong? What are we going to do about it? And have we done enough? His 4 questions. And that's as good as anything else that I've found. But these are some of the things that are in the model to help you wire down. What are we talking about when we talk about threat modeling? We're just talking about thinking through things that can go wrong, usually from a security and privacy perspective, but it doesn't have to be limited to that. And then try to do something about it. What are we gonna, what can we do? And maybe, as Denise said, you accept the risk because there isn't anything you can do about it, or you don't want to spend the money. These are good decisions. These are good discussions to have. It's not like security, you have to win all the time. But nevertheless, this will give you some definition if you need it. Here's some more wisdom from it. I didn't put the whole thing up here. It's a little bit bigger than this, but here's some interesting thing. We're trying to improve the security of the system and the privacy, and we do it iteratively. If you're working iteratively, your threat modeling has to be iterative. I don't have those slides here. That's a whole nother presentation, but nevertheless, think iteratively. I personally am a big fan of iterative development. So, that comes across, I'm sure. If you don't like it, still don't wait to threat model until your architecture is done, because it's too late, because you're just asking for rework. The output of the threat model, it's got to be meaningful. If it's stride, and that doesn't help at all, then why do it? I find in my practice, the dialogue is critical here. It takes a lot of people. I like to say it takes a village to threat model, because I can't tell you the number of times I have been sitting there and the lead architect has been drawing, Isar's going to love this, has been drawing on the board, and one of the developers says, that's not what we implemented. That's not how it works. Oh, this is cool. Yeah. Somebody get the poll. Would have been good to tell me we were doing a poll. I wouldn't have kept talking, but yeah. So this is cool.
I
Let's
was
see
just
what we get.
experiment. I saw a pool there, so let's see if we,
Yeah, no experiment. Let's see what people say. I'm really curious.
this is actually quite cool, actually.
Yeah, good.
Actually, we probably should do some of these pools in the beginning of the session, right? To get
Yes,
us
we
going.
should,
Yeah.
but you know, it's okay, whatever.
Cool.
Again, iterative. What do we need? Okay, let's change what we're doing so we get more. We got 14 folks. This is pretty interesting.
Yeah. All right. I'll leave a couple more minutes, then you can continue. Yeah.
Yep. So this gives people a little chance to read this slide too. It's a bit wordy. I don't usually like wordy slides, but I wanted to get as much of the manifesto stuff onto this. Okay, so let's see
Oh,
what it
I
says.
know. I think it's because you are a co-host.
Yeah.
Yeah, I think Ben, both of you guys, we made you co-host. You could present. So.
So let's read back on this. Some of us are secure, you know, some people didn't answer, that's okay. But lots of us are threat modeling. So I hope you get some tricks here and some new information. And some of us aren't. And I'd be curious to know why, because a lot of times when I ask people, are they threat modeling? They're thinking of, well, I'm not doing stride and I'm not producing a document. So no, we're not threat modeling. And then I talk to them about how they design and they're like, yeah, we're considering attacks. We're mitigating attacks. And that's essentially threat modeling. Again, best use of threat modeling is to improve the security and privacy of a system. It's not, you know, they're not formal, but it's okay. Maybe you really are threat modeling. So, you know, you might want to rethink that. And maybe you're not at all, which I have found too. Some security champion questions here, which is curious. Lots of people are federated, not everybody. And some folks are having their developers doing the threat model, which is great, I think, personally. So I'm gonna get rid of this poll.
Yeah,
you know, it's a bunch of wisdom here that you might consider in the threat modeling manifesto. And you know, I'm not going to go over all these points, but please consider it. Go look at it. It's Creative Commons license, so it's free for you to use. No restrictions. Some of the biggest recurring problems I see, is this, oh, well, we're not producing a formal document, so we're not threat modeling. The formal document is an aid or a capture of what you have. It's not the threat model. So let's be clear. One of the things that, depending upon your context, you may have to produce a formal model because you may be asked about it, or you may have compliance. That's fine. But if that's not true, a picture of your threat model that you drew on the whiteboard that you just capture to your wiki may be more than enough, so you can refer to it. My friend Owen Carroll, who might even be on the call here, I don't know. He put up these gorgeous threat models in all the stand-up rooms. He was the lead security architect at one of our development centers, and he put up these gorgeous threat models in the stand-up rooms, and organically, because suddenly it wasn't something off on the side, but it was something that could be considered, all the teams started going, oh, this has security implications. Look at that. Oh, this one doesn't. We don't need to deal with security with this item when we take something off the backlog. And they started considering security vis-a-vis the threat model for every item as they pulled things off the backlog, you know, for the beginning of a sprint. It was just all organic and it just worked. And so, you know, that's making it available and letting people have it encourages people to use the information and to participate. So one of the big problems I see over and over again is the lack of understanding of the relevant attacks, because developers, and this is a stereotypic statement, so take it as that. Any one developer could be wildly different, but but typically and often, when I ask people about their threat model, or when I teach, and I've had thousands of people go through my threat modeling classes, what people will do is they'll think about the things that affect their functionality of their software. And I'm not saying that's not important, that is, but they constrain to that because that's what they're focused on. And the thing is, when attackers look at a system, they're thinking about how they can use it for their goals, not your goals. So their goals may have nothing to do with the functionality of your system. Take, for instance, a botnet, or use of your systems, systems to attack other systems. That's got nothing to do with your functionality, quite likely. However, that might be very useful to the attacker. And so one of the big problems is open up your view. You have to think about, what are the goals? This goes back to what Denise was saying not very long ago. What are the goals of the attacker? And what are they trying to achieve? And how could your systems be used to achieve those goals? And some of that may have to do with your functionality, but some of it may have nothing to do with your functionality. And so trying to get away from just thinking about, solely thinking about, what you're trying to build and what it's supposed to do, as opposed to what the attacker may make it do. The other thing is, it's very hard for people to get enough information about the kinds of attacks that will be levied against any particular attack surface. And I haven't identified it. I haven't defined attack surface, but that's a place on the system where an attacker can get their initial entry. And there's not a universe of attacks for each of those. They're very specific attacks. If you have a CLI, that is a command line interface, certain attacks are possible and certain attacks are not possible. If you have a web thing, and there's a lot of great documentation about what's appropriate for web, there are particular attacks that are useful and relevant, and others that have nothing to do with that area. And so understanding that particular threat library, if you will, for your system is a piece of the skill. And there's a wonderful new kid on the block around this. If I can just underline it for a moment or give it some highlight, and that is a MITRE's ATT, ATT&CK library. A lot of great practitioners have contributed to that, such that you can just go dial up in a layer how an APT, what techniques they use, and it will show you APT 9 used these attack methods. It doesn't wire them in the exact steps, but it gives you the methods. And you can use that as a way of kind of finding, I've got a web interface. What things have been successful against web interfaces? Well, you can go to attack and say, HTTP, and it'll give you the universe of stuff you should consider. That's very important. There's also the NIST mobile threat library. That's very good if you're doing mobile. There's resources out here. You don't have to make this stuff up yourself. The other thing, and I've already made this point, is that folks focus too hard on technical trickery as opposed to table stakes. I see that over and over and over again. The engineer wants to get down and dirty. How are they going to misuse the Bluetooth stack when there are tons of, there's no control over who has what access. And, attackers are lazy. Essentially, you give them the keys to the car. If you leave the key in the car and you leave the door open, somebody's very likely to jump in your car and drive it away.
I would use the word efficient, not lazy.
Yeah, okay. Fair enough. We look at only today's issues. I see this quite a lot as well. I find this weakness and I find that weakness and I want to address them. But part of the art of threat modeling is actually speculative. Not speculative in that I want to invent entirely new attack types. The moment you start inventing entirely new attack types, you're done for the moment, really. New attack types, entirely new attack types, only show up once or twice a year. They're really fairly rare. It's usually variations of stuff we already know about. And that means that you want to apply known successful attacks that have been successful in the kind of functionality you're building and the kind of architecture or technologies you're building. And that limits quite a bit what you need to consider. But you don't want to focus on technical trickery, and you don't want to only use today's issues. It's a little speculative. You want to imagine during the life of this software, I've got a virtual environment, and I know that about once a year, we see a new guest escape issue crop up. And it might not be in my virtual environment. Might be maybe I'm using containers, and maybe it's in virtual machines. Okay, fine. But we know that over the at the rate that they're coming at the moment, we know that sometime in the life of your software, probably there will be a container guest escape that is getting from the guest, the container, to the host and taking it over, because they do show up once in a while. And have shown up in containers, by the way. And so you want to consider that, even though there isn't one today to worry about. You want to consider whether you might want to do something about it, because it will show up. And that's the art of threat modeling. There is a little speculation here, but it's not speculation as in I'm creating whole new worlds. It's I'm applying that which we already know exists and will come up, even though it doesn't exist in the system, to the system at hand. And there's the imaginative part of threat modeling. Don't just limit yourself to today's issues. Think about what could be tomorrow's issues and prepare for them today. One of the biggest problems we have in threat modeling and generally in security is poor risk rating. Unfortunately, most companies use CVSS, which is demonstrably, there is a body of research on this since 2014, demonstrably proven poor at predicting whether something will be used or not. It is a severity rating. I'm not saying we should throw out CVSS. I've been working with CVSS since before version 1. I'm saying use it for what it's good for. Don't try to use it as a risk rating, because it's not meant for that, and it can't do it. There are some bright lights maybe coming, like EPSS, exploit prediction scoring system. It's not operational yet, but maybe it will be. I'm praying, because I like that research a great deal. But nevertheless, risk rating is a problem. Don't just use CVSS. At least take a look and decide whether in your context, what the likelihood of success is, and what the impacts will be. Because sometimes things that have terrible CVSSs have minimal or no impacts in certain contexts. For instance, you're carrying around some vulnerability that's terrible in an open Linux system, but in your Linux image, it is never called. And the only way it could be called is by the root. And if the attacker already has root, why are they running an exploit? They already own the machine. So, that's just that kind of simple analysis can improve your risk rating a lot. So that's a big problem. Having limited knowledge of relevant attacks, and we need to, and the appropriate defenses, because attacks to defense is an end-to-end relationship. It is many to many. One defense might protect against a slew of attack types, whereas some attack types really need only, they need one single defense, and then you may put other controls around it to sort of beef things up to build a defense in depth. It's not necessarily simple and, I've got this, so do this. There may be do this and this and this and this, or, and that's a little bit of an art. Interestingly, again, MITRE went to the trouble of building up typical defenses and building an ontology from those defenses. That's defend D, 3 FEND, to an ontology that works back to the attack types in attack. And so that whole body of knowledge can help you greatly improve your attack and defense knowledge and your threat libraries for your technologies. Really great resources. Or you can hire Denise or Isar to come and help you, because they carry around this stuff in their heads, I'm sure.
Yeah, but that doesn't scale.
Yeah, that's the problem. That's one of the big problems. Remember, my context, 28 million programmers. And we really need most of them to be threat modeling successfully and effectively.
Yep.
Most of them, not 1 million of them. So we gotta somehow make this easier and part and parcel of what you learn and do as a developer, as an architect, as someone involved, as a security person. I do want to note that there are some different types of threat models. We've been talking about the bottom here as a foundation for secure design and secure architecture, secure structuring, building secured systems, and privacy as well. Let's not lose that thread. Although I'm not a privacy person, so it's a little bit outside my scope of practice. But there are other reasons to threat model, and people do. If you're doing especially manual testing, usually the tester, if they're any good at all, has some sort of threat model they're working from, even if it's just mental. They've already threat modeled where the attacks are most likely to succeed, because they don't want to waste their time. They're not just poking around. And so that's one level of threat modeling where you're just interested in the attacks. People do threat model just to uncover risks. I've never really understood that practice personally. That's a personal aesthetic, if you will, in my security practice, but I know that people do. They do a risk assessments, which is essentially a threat model, and then they raise risks, and that becomes part of a risk management system or understanding. But I don't know, if you raise risk, don't you have a responsibility to think about it? Anyway, that's a superset of the first one. And then, of course, the last here, they're all supersets. When you do security design and you're threat modeling for that, you really need to consider attacks, and you better be able to risk rate those effectively. So they're supersets. But you will find that people do threat model just as a risk assessment. And I guess the big accounting houses make a lot more money than I do doing that. So, interestingly, as Intel's version of a distinguished engineer, which, if you had said that to me 40 years ago, that I wind up to be that, I would have said, you're out of your mind. However, life is interesting, and that's part of my journey. But as a security person, I was asked to sit on their review board, and anything with security implications goes through, or did go through, a very intense review board system with the principal engineers, or their distinguished engineers sitting on it, not only, but a lot of them. And one of the interesting things that I became aware of as sort of a participant observer, if you will, is, of course, I was doing the work, but I was listening to the questions that people were asking and what they were saying, my peers. And it became utterly apparent that no matter what level we were working at, we were all threat modeling in our heads. Now, maybe the output of that threat model was different, and the granularity certainly could be wildly different. You know, if we're just trying to decide if something has security implications, we're just trying to generally figure out, you know, could it be attacked? Whereas if we're actually trying to come up with the threat model and vet it, then that's very different, and we're really doing the detail work. But nevertheless, it was threat modeling all the way down. And it convinced me that we've overcomplicated software security, the design part, by having the initial architecture assessment, then architecture review, then security architecture review, then threat model. If I were a developer and somebody presented me with those 4 things, I'd say, what is all that? Okay, can it be simpler? But it is incredibly much simpler. In my mind, and today in my practice, it is all threat modeling at different levels and for slightly different outputs in granularity. One, we might, that initial idea, we might just be looking for, you know, major requirements. This is going to need authentication and authorization. You know, just really general things. During the architecture.
Yeah, but let's just a small point there, right? I think that we also should not shy away from the fact that when you're doing these threat models, right, you are doing architecture reviews, you are doing detailed flow mappings. And the reason I like to do it in layers is because software is complex, right? In fact, sometimes the worsely designed the software, or the more, you know, there's a direct correlation, maybe not worsely designed. The software that sometimes has a number of issues, right, or grown, you know, in lots of different ways, tends to have bad architectures, right? Tends to be sometimes glued together, done by multiple generations of developers and teams, right? Sometimes even acquisition stuff, or sometimes using frameworks that, you know, are now way, you know, out of date or insecure. But it is complex, right? Because you're looking at architecture, you're looking at how software is glued together, and software can be insanely complex.
It can be insanely complex. And that's another sort of trick, which I didn't put on these slides for you know, to help. But you bring up a super important point. It's an architectural point though, and threat modeling benefits from it, because I believe in order to be a decent threat modeler, you have to understand structure and abstraction. And that's what architecture deals in. But an important point is you want to not try to do everything at once and go down, you know, it's good to do things at levels and do sort of the whole overall architecture, and then drill down into this piece and drill down into that piece and get, you know, and you know, as we will look in the COVID app, if we get there, threat model that I've got queued up here, at some point you really do need to look at how the Bluetooth a notification or understanding of who's in your Bluetooth area, how that works and what vulnerabilities might be there and what protections you need. You do need to go down that level, but you also need to work at a much higher level. And that's kind of the art of architecture. It's about abstracting what you need to view while eliminating anything that obscures what you need to view. So it might be very detailed, but hopefully scoped, so you're not trying to get everything on one page, so you can, you know, it's an eye chart. And at the same time, you need the overview as well. What were we going to say, Denise?
That's why you need the layers, right? The layers.
Yeah, exactly. Exactly.
Makes it rational. And I have to say that I'm actually in a couple of, you know, places where, you know, I'm basically helping to make the business case to say that, you know, you want to use threat model as a way to document what exists, right? As a way, you know, and one of my roles, right? You know, I'm a CTO and a CISO, right? So I get to talk to myself, right, and say we need threat modeling because we need, you know, to understand the flows, and we need to understand how things are glued together, right? I feel that we from a security point of view, we can actually even fight for budget to allow us to do that, right? Where we say we're going to add value to the business, not just on the security element of it, which is important, but we're adding value to the business because we're helping to document what is actually happening.
So as a CISO, let me ask you this.
Yes.
You can kind of validate or poke at my concept. I believe you can't be a CISO unless you threat model your whole organization and its security systems and its other systems. That ultimately you have to have a threat model for your organization.
Yeah, absolutely.
True statement?
Absolutely. Well, I would argue that, because I have a development background, I approach my world as a bunch of modules, right? I'm just coding at different levels of abstractions, right? But you are completely right? I think you do threat model, right? Whether very explicit or implicitly. And you basically, if you have threat modeling experience, you can do that in your head, right? One of the things that I'm not sure if you mentioned here, where for me, a massive thing connected is wordly maps. I don't know how much you look at wordly maps, but
you and a couple of my other friends keep pushing them in my direction, and I keep
to
trying to study them, and I look at them and go, it looks kind of like a mind map. There's something here I don't understand.
All right,
so I have to admit, I haven't gotten into it.
Let's do a session for the next summit on just wordly maps and threat modeling, right? And I'll walk you through the thinking.
I would love it. I would love it because I think I'm missing something here.
Yeah,
pretty powerful.
Wordly maps gave me a piece of the puzzle, which was context and situation awareness and movement that you don't have in threat models, right? Where, and he clicked on me when in one of the summits where we were privileged enough to have Simon Wardley and Adam Soshak and a bunch of other guys that were there, right? And I basically had these guys all talking to each other, and suddenly I realized this is the missing piece for threat modeling, right? Wordly maps allows you to have context, allows you to have movement, allows you to, have a lot more situation awareness of what you can do with a threat model, especially on some of the diagrams and some of the architecture documents. So cool. Let's do a session next summit, and then we explore it.
I'll be there. So though I'm not a Wordly map person, I do want to say that this is how I do threat modeling, and I believe it's very effective. And like I said, I've had thousands of people come through my classes. I've trained hundreds of security architects. That's not a brag, it's just a fact. Just been around a long time and been a security technical leader for a long time. So this is my job, right? And I like to focus on really credible attack scenarios. Yeah, I think you said this earlier, Denise. You were talking about this. I want to know not that all things are possible, but what things might succeed and how they might succeed and how they might proceed. So you have to understand a little bit about how attackers start and then take the next step and what steps they might take. And that's very important. If we were to go back to the solar winds, I got the O365 account. Okay, can I now look through what I have access to see what my next step is? That's how attackers work. And they find out, oh, this same password is being used for this other thing, the repo. I mean, I don't know if that was actually true, so careful here. But let's say that was true, just hypothetically. Then okay, now I got the repo. What can I do with that? And that's kind of how attackers work. And so they do things in steps, unless you get game over on the first step. There are vulnerabilities.
But even if you get game over, right? They still need to do things, right?
They still need to do things. That's true.
There was a guy that had for me one of the best quotes ever. He says, "A 0 day is not an invisibility cloak." Right? It doesn't make you invisible, right? Like, yes, you might even hyper jump straight into the middle of your most valuable assets. You still have to get them out. You still have to exploit. You still have to probe around, right? So if you paying attention to your signals, and this is what, like the word you have there, I love it, credible, right? That is such a powerful thing, right? Because the attack scenario is not just the first one, right? Is everything that happens for that to be successful.
Right, exactly. And all the context for it to be successful. So if some of the context is missing, here's one of the things, having worked PCERT a lot, product incident response, as the most senior person, if it's big, it's going to come on my desk, even there are other people who are handling it. Generally, the smaller ones, if it's big, execs expect me to be involved and expect me to be leading. And I'm happy to baseline that. That's, part of my job. Denise would expect me, if I was this senior security architect, if there was a major incident, to lead on it, right?
Yeah.
Duh. And because of that, I'll tell you, a lot of times, interesting, you get these things where the conditions of the report are somewhat artificial. And so the likelihood that it will actually happen in the real world is much smaller than the base CVSS score indicates, because the context says, actually in the real world, those 4 conditions don't obtain. You never get those 4 together. And we have the telemetry to prove that. None of our customers actually run it that way. And that's very important. That makes the attack scenario much less credible. And I want to worry about that much less than the one that is credible that could kill me tomorrow, or is killing me now. So yeah, credible is a very important word here. It's my word. Nobody else uses it as far as I know, but you really want to think about the context as you think through these things. And again, and that comes with experience and some analysis. You want to think about impacts, because if the impact is negligible, then why are you worrying about it? Again, I'm not a fan of attack trees. That's kind of yesterday's technology. And I'm not a big fan, because you waste too much time. I waste too much time, and I'm very, very careful
I
with my
like
time.
attack chain, right? Which is the
Yeah.
sequence of events
Yeah,
required.
kill chain, yes.
The kill chain,
Yep.
yes. The
Yeah,
kill
yeah,
chain, right?
and kill chains are, but some kill chains, if you really get to the kill, then it's credible as well.
Well, that's the point, right? The kill chain, there's a moment we realize that you're now going complete off the rails, because it's not credible anymore. It's not because you can jump from there to there that it would actually happen, right? So the thing I would add just here is that, most businesses, if they pay attention, they have the data they need, which is basically would come from their incidents, right? Because their incidents, or let's say the incidents in the industry, should help you to get data around how credible an attack is, right? Because then what you want to say is that, look, although that thing might be more vulnerable over there, actually this kind of problems here, or this kill chain over here, or this credible attack scenario is much more realistic, because I have data to support it, either to us or to our industry.
So if you are seeing, to your point, if you're seeing, and I've had a couple of jobs where this was always true, that you always have a population of a few compromised boxes or accounts, then you're taking it, nothing ever happened, so I guess I'm okay. I mean, that's powerful information, that you're going to have a compromised O365 account that then can get to your repo, your build system, and your SAML keys. So, that's really good information. You have that data. It's there if you want to look at it. Or your managed service provider, your managed security provider has that data, and you can look at it, or you should be able to.
I remember, in my early days of owning systems, coming out of a pen test or a review, being all happy, going, this was insane. Look at what we discovered, what we exploit. And then you have this question going, some of these things were so easy. Why haven't these been exploited before? Right? Like, it was not that some things you do, you could see was pretty advanced, but others were just like,
table stakes.
The attackers were just not there, right? Like, and now realize it's not even sometimes that the attackers were not there, was that combination of the attack with the motivation, with the motive, with the company, with the exploitation, etc. And like the threat agent that we talked about made it actually say that although this was vulnerable, that particular exploit was not credible, right? Because it was just not happening.
Yeah, and I want to point out that something like, and percentages different and differ in different research, but something near 80% of what is reported is never used, ever exploited, ever, ever, ever.
No,
So, you know, that we're interested in the 18%, or is it 26%, or is it 12%? I've seen all of those, by the way. In different research comes up with different numbers, but it's a very small number. Let's say at least 75% of what is reported will never be used ever by anyone. So you got to get rid of that dross. That's not a, I won't say it's a trivial problem, but it's a problem that's part of the work here. Going along in the threat model, just to help you all, for those folks who need this, and everybody else, you can quick look at your phones. You want to describe the weaknesses that allow exploitation. This is important. You don't need to get down to bits and bytes, though. One of the problems, one of the differences between pen testing and threat modeling is we work with types in threat modeling, but in order to actually successfully attack or build a defense in a piece of software, you have to know the bits and bytes. I do not need to know the bits and bytes of every single buffer overflow or every single cross-site scripting to understand how it works and what the vulnerability is. I do not. We work at a much higher level, even when we're working very technically. On the other hand, sometimes in order to assess, you can go out and read my analysis of Heartbleed, our world's first branded vulnerability. If you want, it's still up there from whenever that was, 2014 or whatever. It's still up and posted in a couple of different places. And you can see how deep I had to go in order to do that. And it was quite deep. You have to understand stacks, you have to understand the keep alive and the TLS protocol. You know, there's a bunch of very technical things you have to understand. I even went and looked at the open SSL code to understand how it all worked and how memory worked. Yeah, so you might have to do that. I'm not saying that you don't, but a lot of times we don't need to go to that level of detail. We can just work at types. But you do have to understand the weakness at that level. And again, I said today's weaknesses and tomorrow's expected. And we risk rate, remembering that probability times impact is not a simple number in the absence of actuarial tables. We do not have actuarial tables that we can rely on. I point out that people started keeping actuarial tables, what we now think of as actuarial tables, in 1606 in England. And they are universal, and we have hundreds of years of how likely it is for someone to die of a heart attack at a particular age. We have those tables. That's what insurance is built on. We do not have that yet in the security world. We're starting to get some of that. Poneman Institute has done a lot of really great work in this arena, but it's very limited in what they've focused on. So there's a problem there. And the solution is casino math, which is hard to set up. So, you know, coming up with that probability number is not trivial. There's things you can do, and there's things I've proposed which have been field tested by thousands of assessments, and you can go look at that stuff. And there's other methods, but you have to use some method to come up with that probability number. The impact, it turns out, is fairly easy to get. You can do classic annualized loss if you like, but you know, figuring out a scale 1 to 10 or 1 to 500 or whatever numbers you want to use, it's not too hard to scale impacts, it turns out. But the probability is a problem. So that's something you want to work on, and not just put your finger up to the wind and say, oh, I feel really uncomfortable, so I think it's high probability. That's not a good, we're not, when I'm threat modeling, I'm not really interested in my risk tolerance. I'm interested in the companies or the organizations. And then we figure out what to do, today's and tomorrow's, to address each weakness. This is what threat model basically is. And in a nutshell, you apply known successful attacks, today's and likely to succeed tomorrow. To points on a system, we call those attack surfaces, that attackers can reach. And you think through, how could they reach that point, who might be able to reach and who might they be, to Denise's point. You assess potential impacts, you rate the risk, and you identify appropriate defenses. It's not that hard conceptually. It really is not. And like I said earlier on, you all do it anyway. You wouldn't be getting in your cars if you didn't have a threat model around that. Now, maybe your threat model is nothing can happen to me, but you do have a threat model of one kind or another. So this is Jakub, I think that's how he pronounces his name, I hope, Kaluzhny. And he did this a couple of years ago, just as COVID was getting started. And it was fantastic work. I know this isn't a very good, he didn't have the original image. So I just took a picture, I just took a screenshot of a point in his presentation, the video, to put up. So I'm sorry, it's not very readable, but just sort of get a general sense of how he was approaching threat modeling as a technique. Anybody want to speak to this as a technique? Getting it visual, understanding the components, and then using these, in this case, he used yellow as a threat and attack vector, and blue as a potential defense. Just take a gander at this visually, and does this suffice? Is this interesting? Do you get the sense of the threat model here with some arrows pointing how things, different flows work? Any comments? If not, I thought it was really a good start, a really great start. And so I had promised to do a threat model for an open source project, COVID app. That's an open source project that is now like generations down the line, and has lots of customers, various states and other governments around the world. And they've gone off, and I haven't worked with them in a number of years, but I said I would do a threat model. And I found this and said, wait, Jakub's already done this work for me. All I need is to improve it a little bit. And you can see what I added. Now, I wasn't using Miro. I think he used Miro. And so he had this nice shadows on his stickies. Mine don't have any shadows, so you can tell what I added pretty fast. But I added some stuff, and a lot more, my green is like things we don't have to worry about, because they're kind of out of our hands. And I added a few yellows, but I thought he got the attacks pretty thoroughly, at least at a high level. And then I added a lot more stuff you got to do. And this is all mostly table stakes stuff. So you can take a moment. I think this is a lot more readable, because actually I have the image. I didn't keep the original, unfortunately, that I started with. But this is my addition to this. I think, you'll notice that I added one more attacker. It's on the bottom right, black circle. And this was at the time, may still be, but at the time it was really hot. Security folk and researchers were screaming, no, we shouldn't have these kinds of notification apps because they're just a bad idea. And so I put them as a potential adversary because I felt they'll be gunning for our app. They'll be looking for anything they can find to say, yeah, see, proved me right. And unfortunately, that does happen a bit in our world. So I consider that adversarial.
I just added to the chat the video for that session from the 20.
Oh yeah, good. Yeah, because it was a great session. He's a terrific practitioner. I don't know him particularly well. We've exchanged, the odd message once in a while, and the odd comment on something. But seems an interesting guy, and he certainly knows what he's talking about. And I love what he did with this. So I added a bunch of stuff, and you can see that the stuff I added was really quite high level, because this goes back to this, my point about if you've left the keys to the car sitting in the ignition, or if it's a keyless ignition, and you've left the fob sitting in the central on your dash, and the door's open, obviously someone can steal your car very easily. They don't really need to get in and worry about how the ignition works, or attacking your infotainment system. They can just get in the car and drive away. In fact, gruesomely, years ago in San Francisco, when biometric, fingerprint readers were coming in on cars, awful attackers were coming up to people and just trying to cut their fingers off to steal their cars. Not the best solution. I'd rather hang on to my fingers than my cars, I can just tell you. Yeah, so, you got to think about these things. At any rate, I added a lot of robust stuff here that would, I think, improve their overall security. One of them was, you got to have a SDL, a security development lifecycle, and you got to be doing some stuff around it. For instance, really basic stuff that, as far as I know, they hadn't really thought of yet. And there's a bunch of very simple things that were not too hard to implement that would help. Just simple things like not everybody having access to everything, and thinking about who needs access and for what reason. I'm personally a big fan of time-limited access for privileges. You need to do something privileged on this system. We give you an hour to do it or 3 hours to do it, and we log everything you do, and otherwise you have no access. Not a lot of people use that, but I'm really a fan of it because it means we can directly tie behavior to a particular user, and mostly nobody has privileges. But
see, but that is a good example, right, of something that we from a security want, but it requires a massive amount of engineering effort. Now, I would argue that
way too much.
The application would be better off. I would argue that an application that can do that shows tons of gaps in how they manage data and will have tons of performance, reliability, stability problems. But it's a good example of almost like a common sense requirement that requires a lot of engineering effort to make it work.
Right. And so you don't get it. And it's just too, that's part of our role. It's a conversation. Okay, I'm a big fan of that. And I have never yet won it in any conversation at any role I've ever had, ever. I know it exists and there are tools to help you do it. I know one place where it was implemented, and it was actually early in on Azure before they had their key management systems, their virtual hardware security module that they now have in Azure. But early on, the way they were managing customer keys was they had a bunch of servers and nobody had access to them. And it was a separate group who would okay any access to them. And yes, they monitored everything that would do on them and whatnot. And I thought it was quite good. So I do know it has been done, personally, but I've never been able to make it happen. And that's part of the conversation. Exactly what Denise said. If it's too much engineering effort and we spend the next 3 years doing that and not building product that gets us revenue, that's a very bad decision, in my opinion.
Yeah, but the trick is to align that to the areas where that will make the customer, the product go faster. Where, yeah. The more I do engineering, the more I can completely see a connection between, doing that, for example, effort in isolation wouldn't add a lot of value. But if you do a refactoring of the engineering application in a way that having what you just described becomes a side effect, right, of engineering decisions, that has amazing benefits for the business. The challenge is making that business case. The challenge is connecting the dots so that everybody from the business to the product to the security, everybody's aligned that you're going to make those changes, and it's going to require engineering effort, but the benefits are not just going to be security, they're going to be business benefits.
And you got to have business benefits. Obviously, if you're handling customer keys for DRM in the cloud, you'd better be able to secure them. So there was a business driver for Azure to do it that way and to implement that, because like you just said, Denise, there was, then they can talk to people like me and say, here's how we're doing it. Is that good enough? And I'm like, yeah, it's really good. Wish I had that here. There was a business driver, and which brings me to another interesting point that I use a lot, is if I can pawn something off to someone who has a business driver to do it well, I really like doing that. Not invented here, just I don't see the point of it. For instance, there's a lot of things that the major cloud vendors do that they can do way better than most IT departments. And for that reason, if I can pawn off the responsibility to them, I'm very happy to do it, because they have a business driver for doing it. And that's important to realize. They have a reason to make sure that their patching happens really effectively. Whereas you might let that spring vulnerability lay around for too long, until I think Equifax is still paying out the nose for their breach. Yes, they are. And they knew all about that vulnerability, but it wasn't up on the top of their list to fix. And so, that's something to consider. So I'm a big fan of putting somebody else on the hook for things that I can't do particularly well. Any comments on this threat model? I will say that when I presented it, an engineer immediately said, yeah, but what about the Bluetooth down here deep in the heart of the app? And I had two comments for that person. One, we had done a lot of design around that, and it was well documented. And we had made sure that it was well documented, and there had been a lot of design work, down deep in the protocols. But also, you're dismissing, again, it's this fascination with the deep and the sophisticated, when I'm just going to leave my key fob on top of the dash. And that's what a lot of this stuff is about. All the stuff you need to do in order to make sure that you don't leave the key fob sitting on the top of the dash, and make it easily, stealable. And I encourage you, when you threat model, to look at the obvious things first, as well as doing the deep design. But make sure the gate to the barn is closed. Absolutely ensure that the gate to the barn is closed, and that's what I wanted to do for them. Whether I'm pretty sure they found it useful. But these are the sorts of things you'll see. It's pretty high level. Nowhere on there was there anything about protecting signing keys, though they had all this stuff around, signatures built in. You got to do that. Your crypto is only as good as the protection of your keys, as we saw in the SolarWinds. So, that's very important and needed to be attended to. So I got that up there. Any comments on this? Anybody want to jump in here? I mean, I encourage you to jump in here. Hopefully this, was useful. That's all I got to say today. And I thank you, Denise, for all of that. I'm just taking a look at the chat right now, put it on my other screen just to see if there's something I missed. Anybody have any questions?
I think we covered all. I was keeping an eye on it. I think we covered a lot of the session. Yeah, a lot of the comments in there.
Good. I mean, there's some real heavy hitters here. Avi D is also one of the authors of the manifesto, and he's on the call. I see. Anybody else here? From our crew. So he gets credit there. Isar, of course. Greg Reber is an old friend of mine, Aztec Security. I see a lot of interesting people here.
Yeah, well, for a while now there was a pretty good crowd, right? I think now, we're almost 2 hours in, man. So I think we lost a little bit of the crowd, but there was definitely a lot of heavy hitters. So look, I'll start the recording. This has been really, really powerful, man. And there's a lot of great nuggets that we're going to try to extract and create smaller videos for some of the bits here. And that's definitely, there's a couple of sessions that we need to do on the next one. So,
well, I'll mention that I want to talk, and this is the first time I've ever gotten to talk about it. And thank you very much for letting me do this, folks at the Open Security Summit. I want to talk about technical leadership. It's another piece of something I'm really passionate about and have tried to learn to do well. And that's on Thursday. So I invite you, folks, to come to that session as well. I really want to explore what we all think, makes a great leader and what makes not such a great leader. And kind of see if we can build the picture of who's a leader and why.
Yeah, now that's a very important topic right now. And I think there's lots of times where in security, we have to accept that we need some strong leadership, right, in order to drive some of these things forward. But also important to know what somebody's good and what somebody's not good at and how you structure teams like that. So yeah, I'm looking forward to seeing that too. Cool. All right. Thanks, everybody.
All right.